All right, so this is lesson 6.3, simplifying complex fractions with rational expressions. So we've been doing lots of things with rational expressions. Remember, an expression is something that does not have an equal sign in it. So we're just going to simplify it, okay? And we have done just simplifying a rational expression, which is one polynomial divided by another polynomial. We did multiplying, which was so easy. We just simplify everything, factor it down as much as we can, and multiply straight across the top, straight across the bottom, and then cancel what we can. So easy to multiply. Division is almost just as easy because we know with division, we just keep change flip. We flip that first one over, and then we change the sign from division to multiplication, and then we're right back to a multiplication problem. Okay, and then we got to adding and subtracting, which it was a long time ago because we had our break. So adding and subtracting rational expressions, remember we have to get a common denominator. So the nice thing about 6.3, the simplifying complex fractions, is we're going to kind of do all of that with this lesson. So it says a complex fraction is a fraction in which the numerator and the denominator are both fractions. So like in number 1 right here, this a over 2 divided by a squared over 4, this is a fraction divided by another fraction. I think we already know how to do that. This is just written a little different. So these first few start out really easy because it's already one fraction divided by one fraction. They get just a little bit harder when we get over to the back side, where when we have the top, it's two fractions that we have to subtract first. And then in the bottom, it's already one fraction. But in the top, we have to get it down to just one fraction first. So we're going to have to do subtraction, then we do the division. Okay. And like in number 15, we're going to have to subtract in the bottom and get it into one fraction before we have the division. Okay, so that's where they get just a little bit different. That's why I said we're going to do all of our operations in this lesson today because we're going to add, subtract, multiply, and divide. Okay, so our steps here go through exactly what we're supposed to do. I just told you what a complex fraction is. The definition is that the numerator and the denominator are both fractions. Now, to simplify a complex fraction, we have to rewrite it as a single fraction. It can't be a fraction in the numerator and denominator anymore. It has to just be one fraction, all right? So we're going to create a single fraction in the numerator and the denominator. So these guys start out that way. We start out easy where they already are a single fraction. On the back page, like I said, we'll have to get it, add and subtract first. Then we have to set up a division problem. Then we multiply by the reciprocals, which we know is the fancy terms for keep, change, flip. And then we're just going to simplify where we do our factoring if we can, if possible, and then simplify. So let's get started. These start off really easy because we already know what to do. We already know how to divide a divided by 2 divided by a squared over 4. I already know that this is just the division sign. Okay, so this is the same thing as a divided by 2 divided by a squared over 4. It's just written differently, okay? The fraction bar is the same thing as the division symbol. So I won't rewrite this like this every time. I just want to do this on this first one and talk through it. But we already know how to do this, guys. We did this back in section 6.1. We're going to multiply by the reciprocal. That's the fancy words, right? Because our steps say create a single fraction in the numerator and the denominator. Done. Set up as a division problem, then multiply by the reciprocal, or what I like to say, keep, change, flip. So from this point, I'm going to keep, change, flip. So I'm going to keep the a over 2. I'm going to change my sign from division to multiplication, and I'm going to flip the back one into 4 over a squared. Now, this is really easy. I just multiply fractions. We just multiply straight across the top and straight across the bottom, no problem. So this becomes 4a over 2a squared. And now I just need to simplify. So I'm going to take the 2 divided by 2 is 1, 4 divided by 2 is 2. And this 1a can cancel with one of these, leaving me an a in the bottom. So I'm left with just 2 over a. All right, no problem. In the second one, I'm going to go ahead and keep change flip. I'm not going to write this out as a division problem like this because we already know that that's what that is, okay? So I'm going to keep this one. I'm going to change this sign and I'm going to flip this guy over. So 6 over xy times, change my sign, and then flip the bottom one. 8x cubed over 3y. Okay, flip the bottom one over. Now we know with division, technically all we're doing is, or excuse me, with multiplication is we're just multiplying straight across the top and straight across the bottom. And I've told you guys that you can go ahead and consider this to just be one big fraction that of things that can be simplified. So like 6 and 3, I can break that down rather than getting 8 times 6 is 48 over 3 that I have to simplify. I can just take the 3 and the 6 and simplify them down from the get-go. So you don't have to, but it's just a shortcut. 3 divided by 3 is 1, and 6 divided by 3 is 2. And then this x here can cancel with one of these, leaving me 2 in the top, the one in the bottom, leaving me 2 in the top. So it looks like I'm left with 2 times 8, which is 16. And I have x squared left over in the top. And then in the bottom, I've got a y, and a 1, but you don't have to put the 1, so it's just y squared. Awesome. All right, let's go to number 3. We're going to, it's a division because it's one fraction divided by another fraction. So it's this top fraction divided by the bottom fraction. They're both one fraction, even though there's subtraction in the bottom. It's a binomial and it can't be split up. It's not two different fractions that are being added or subtracted. So I'm going to keep, change, flip. So I'm going to take the 18p over 8p minus 2. And I'm going to change it from division to multiplication. And then I'm going to flip 4p minus 1 over 4p squared. Now, I think I see something that can be simplified a little bit here. I think 8p minus 2 has a GCF that will come out of it. So I think if I take a 2 out of this, it's leaving me 4p minus 1. So I'm just going to do that. I'm going to cross that guy out, and I can still see what I'm looking at here to be able to simplify. So I'm just going to multiply straight across. I see the 4p minus 1 and 4p minus 1. I think I can do, it doesn't matter if you do the 18 and the 4, divide them both by 2 if you want to. So, or you could do this 18 and 2. It doesn't make any difference which one you use as long as you only use one. So I'll just do the 4. So divide both of those by 2. 18 divided by 2 is 9, and 4 divided by 2 is 2. And this p can cancel with one of these, leaving me just 1p in the bottom. So it looks like in the numerator, all I have left is a 9 because it'd be 9 times 1. And in the denominator, I've got 2 times 2, which is 4, and then I do have 1p left over. All right, number 4, I'm going to keep change flip. So I'm going to keep this one. I'm going to change this one, and I'm going to flip this one. So keep the k minus 1 over k. Change the sign from division to multiplication, and then flip k squared over, and then k squared minus 1, that's the difference of squares. So I'm going to go ahead and simplify that into k plus 1 and k minus 1. This guy factors right here. Okay, I can put that k minus 1 up there in parentheses if it makes it easier to see what simplifies. So now k minus 1, k minus 1, this k with one of these k's, leaving just 1. So it looks like I have k over k plus 1. All right. I will do these next 4 in the next video.